Okay, let's get started. Let's get straight into it. Linear relationships. All right, we spoke about this, and Billy helped us a lot with this last week. Linear relationships, and that word there is the clue. These are line graphs. Okay, the word line is in the word linear, so we're going to see a lot of line graphs today. We're going to focus in mostly on these graphs because a linear graph, a linear relationship, easily shows us a relationship between two things, a dependent and an independent variable. Okay, so we're going to focus in on these on these graphs today. So let's have a look at some linear relationships as they are represented with lines. The first linear graph, it is a linear graph. There is a relationship here. Okay, so we have the cost of hiring a bus. So you could say that the context behind this graph is that the school wants to hire a bus because they want to take some children out on an excursion, and they're trying to find prices for hiring a bus. And one bus company says, we don't charge per child in the bus. We just charge a flat rate. Okay, you'll hear this word quite often. A flat rate or a flat fee for the whole bus. Okay, which means it doesn't matter how many children are on the bus, it's going to be 450 Rand for the bus for that day. So you can have 0 children, 1 children, or 100 children, doesn't matter. I don't think there is a bus that can have 100, but it's a flat fee for the bus. So this graph is not going to go up as the number of children increases. We can see at the bottom of the graph, the number of children is getting bigger as we go from left to right. But that line at the top there is not increasing as we increase the number of children. It's staying constant. So we call this a constant or fixed relationship. Okay, it's constant. It doesn't change. It doesn't get bigger. It doesn't get smaller. It's constant. It stays the same. All right. So you often see situations and questions where they talk about a flat rate. This is what the graph will look like. It's the same Rand value, no matter how many children there are on the bus. Okay. All right. Let's move on to the next one. We're all familiar with this one. Okay. Don't worry about the 495 at the bottom there, but you don't need to worry about that value. So this is a linear function, a linear graph, and it's also increasing. Okay, so this scenario is as the weight of your tomatoes increases, so the cost or the price to purchase those tomatoes also increases. So we have, for example, over here, 1 kilogram of tomatoes, and then we can work out that we have a cost for 1 kilogram of tomatoes. If I draw a line up, and then I draw a line across, we can work out exactly what the cost for 1 kilogram of tomatoes is. So if you go up from your x-axis on the number 1 and you touch the blue line and then start going horizontally towards the y-axis, you will work out what the cost is for 1 kilogram of tomatoes. Okay, so the cost of tomatoes will increase as the weight of tomatoes increases. So there's a relationship. The cost depends on the weight. So the cost is the dependent, and the tomatoes are independent. The amount of tomatoes in your bag doesn't rely on cost. Okay. But the cost of the tomatoes depends on the weight of the tomatoes in your bag. All right, so we can see what's the dependent and what's the independent here. So this graph is going up. It's increasing, all right, as the one value increases, so the other, and it's increasing on a straight line, so it's a constant increase, okay? So we can say this is a constant increase graph. And this word here, proportion, all right, means that it's going up, it's increasing in the same amount every single time. So if I go down to this blue line that is increasing, and I say, what is the change from here to here? All right, let me try that again. Okay, so what is the change from there to there in terms of the weight of tomatoes? And we can say that the change is 1 kilogram. Well, then what is the change from here to here? Well, the change is also 1 kilogram, and etc., etc., etc. It goes up and increases in the same amount every single time. And for this change in weight, we can go to the other side of the graph and say, what is this change in cost? Well, we can look on the y-axis here, and this value from 0 to 5 is the change for that change in weight. So that's the change in cost, which is 5. Okay, so for every 1 kilogram that you increase, you're increasing by 5 rand every single time. So we're going up by 5 rand every single time. So the increase is constant, and therefore we say that these two values, the cost and the weight of the tomatoes, are in proportion. Okay, they're in proportion or proportional. All right, so this is a proportional relationship. The one gets bigger, the other one also gets bigger, but they get bigger in the same amounts every single time. So that's a proportional relationship. Okay, are there any questions so far? Anyone want to raise their hand and chat about something? All right, then we're going to move on. All right, so that's a constant increase or a proportional linear graph. Now, we have the graph going down in the opposite direction, okay? Now, this is a very important relationship, even if you don't take math literacy or any subject at school. You will eventually have a car one day, just like most adults strive to have a car one day. When you get your job, the first thing you want to do is get your car so you can travel to work. And when you do, you will quickly learn that as soon as you buy that car, its value will start to decrease. Okay, so here we have a graph showing the value of a car. It's in dollars, all right? It's an American graph. So we've got a car that's worth over here about it's worth 17,000 US dollars. Okay, so this value here at the top where we're starting, 17,000 US dollars. So that is in relation to the time at the bottom in years. So here we have 0 years, and the car is 17,000 US dollars. So when you buy that car, that's the purchase price. But after a year or two, the value of that car starts to decrease. And we see on this graph that if I draw a line between the 0 and the 2 exactly on 1, and I go straight up, and then we can see that it's just under 16,000, so maybe 15,900 US dollars. So it's changed from 0 years to 1 year. The purchase price was 17,000 US dollars, and now the purchase price is 15,900 US dollars. Okay, so that car is starting to devalue. It's starting to lose its value. All right, now this happens to all cars, except for some really fancy collector's items, all right, like Ferraris. They don't really lose their values that much. They hold their value. But most cars that we drive every day, they lose their value. So as the years increase, if I draw an arrow over here, as the years increase on the x-axis, so the value of the car decreases. Okay, so this is a constant decrease linear graph. All right, and you do see these graphs sometimes in exams. It just means that as the x value is increasing, the y value is decreasing. Okay, please, and I mean, we love math lit, we all here for math lit, but if you take anything from this lesson, just know that when you buy your car one day, it's going to decrease in value. That's just how it works. All right, so the best thing to do actually is to try and buy your car after it's about a year or so old. right? But because sometimes these cars really drop their value from new. So the best time to buy a car isn't when it's new, it's just after it's new. Okay. Are there any questions so far? Inverse proportion. So inverse proportion is a little bit different to this. Inverse proportion, if I draw it on the graph here, will drop very quickly and then it'll flatten out as you get to the bottom over there. Okay, so that's what an inverse proportion graph will look like. It doesn't decrease at a steady rate. It'll drop very rapidly and create like an exponential curve. Okay, so an inverse proportion graph will do something like that. Okay. Good question. All right, so this isn't inverse proportion. This is just a constant decrease. Any other questions? It was a very good question. Any other questions? Everyone happy so far? I hope you guys are enjoying the lesson, but you're going to be working soon, hey? All right, I hope your calculators are ready. All right, so here we go. Here's an example of an inverse proportion. Okay, so a graph showing the number of balloons each child would get if there are 48 balloons. So you're going to have to give away 48 balloons, no matter if there's one child or if there are 48 children. All right. So if there's one child at the party, he's going to get all 48. If there are two children at the party, you're going to have to split the 48 up into two, and each child will get 24. All right, etc., etc., etc. So 2 children will get 24. 4 children, they'll get 16 each. If there's 8 children, then the number of balloons they'll get starts to get lower. They'll get 8 each. If there's 16 children, they'll get 4. If there's 24, they'll get 2. If there's 48 children, then each one will get a balloon. So this is an example of an inverse proportion graph. We know this because this curve drops very quickly. There's a very big curve, and then it starts to flatten out. Okay, so that's an example of an inverse proportion graph. Can someone tell me, is this a linear graph? This inverse proportion graph, is it linear? As I've got this question mark here. Like, sir, you're talking about linear. All these graphs are linear, and then you hit us with this. What's going on here? Ah, there we go. Thank you. Peter is good with the stuff. All right, good answers, people. Thank you. Good. All right, so I threw in this one because I did a proportional graph, so I wanted to show you the inverse proportion, but this is definitely not a linear graph. Okay, but you do sometimes see them. Okay, now we're going to get cracking with some calculations. All right, so we understand these graphs. We understand what they mean. We understand the relationship between the two variables, the dependent and independent. And now we're going to get stuck into some work. Let's put this knowledge all together. Here comes a contextual question. Get ready with your calculators. All right, let's first look at the scenario. Okay, please don't start doing the question yet. Let's all understand the scenario. So it says here at the top, Nornclear and her family visit an aunt which lives 50 kilometers away from their home. The graph below shows their journey. All right. So if we look at the graph here, on the x-axis, we have time. And then on the y-axis, we have distance in kilometers. Okay. So this is the distance away from their home that they're traveling. So the y-axis is how far away from home are they traveling. So we have 3 sections to this journey. We have section AB, you can see, which is going up there. Then we have section BC. So this is AB going up there. Then we have section BC. And then we have section CD. All right. Now, to understand this graph, well, let's see. Does anyone put their microphone on and help me explain this? I'm very keen. Very keen to hear someone explain how this thing works. We've got lines going up and then lines going across and then lines going down. Can anyone tell me what this section AB is about? What's happening in section AB of this journey? Can anyone tell me? You're welcome to raise your hand or unmute you. You can talk to us. We love it when you guys talk to us. Babalo.
Ready for us.
Pabalo, talk to us. What's happening in section A-B of this journey?
I think in section A-B, she's traveling to somewhere, to her aunt's house.
Your aunt's house, very good. So she's traveling away from home to her aunt's house. So that's the very good, Pabalo. Thank you. So that's the journey going from the home to the aunt's house. Do you want to stay with us, Pabalo, and tell us what's happening in BC?
Yes.
Go for it.
In BC, I think she's already by her aunt's house, just waiting there and staying there.
Very good. Very good. And then CD?
CD, she's maybe going back home or somewhere else.
Yes, very good, Pabalo. Thank you for that. Well done. All right, so that's the three parts of the journey explained. AB is going away from home to the aunt's house. At B, she gets to the aunt's house. And then from B to C, she's at the aunt's house. And then from C to D, she's traveling back. Well done, Pabalo. Good stuff. All right. Okay, now let's see what the questions say. Well, before we do that, though. Oh, the question's going to come up anyway. We'll hit it when it comes. All right, question number 1. Can you guys describe, oh, Pabalo's already answered that one, so we don't have to do it. So he said BC is when they are at the aunt's house. Question 2, state what time Nontle's family left the home to go to her aunt's. You guys can put it in chat or you can raise your hand. What time did Nontle leave to go to her aunt? All right, the answers are coming in. Very good. The answers are coming in. Amo. Yes, Amo, raise your hand. Well done. Amo, tell us. Amo, you there?
Yes.
Amo, welcome, man. How you doing?
I'm fine, good evening.
There's no rain there by you guys, eh?
No.
Okay, we had a lot of rain around here, but it seems like some places got hit hard by the rain last night. Amo, tell us, what time did they leave?
12:30.
Very good, 12:30. So it was between the 12 and the 13, exactly halfway. So they left at 12:30. Amo, well done. We got some other people raising their hand there. Kia, can you see?
Wami.
Okay.
Yes.
All right. Owami.
Yes.
Talk. I've got a question for you. Were you also going to say 12:30 that they left?
Yes.
Okay, I've got a question for you. If you can look at the graph there, tell me, how long did it take to get to the aunt's house?
It took them, took her 30 minutes.
Very good. Well done. I put you on the spot there, but you did well. All right, from 12:30 to 1 o'clock. Well done, Amo. Thank you. Took 30 minutes or half an hour. Very good. Good answers. Well done, guys. Well done. Okay. Here's a question. Somebody raise your hand and talk to me. Were Nontle's family traveling faster going to her aunt or traveling faster going back from her aunt? And if you give me the answer, I also want you to try and explain why you can tell. Anyone want to raise their hand?
Pabalo's so quick.
Babalo. Yes, talk to us.
I think AB, they were traveling faster because the line moves higher up, because it only takes like 30 minutes for them to get there. Then from CD, it took them longer. You can tell the line being more
gentle.
Yeah.
Yes. Gentle gradient. Yes, not as steep. Very good. All right, so you're saying it took half an hour to get 50 kilometers in AB, and it took an hour to get 50 kilometers from CD. So the steepness in this graph here, the steepness of the line relates to speed. So the steeper the line here, the faster they are going. So if I draw another line here, whoops, if I draw a line on the graph like this, okay? Oh, I know what's happening. There we go. All right, so let's say we have this line here. It's a much more gentle angle, okay? A gentle slope of that line. They will be slower, they'll be traveling slower. So they are taking longer to cover a similar distance. So that's a slower speed. Okay, so it's the steepness of a line, the gradient of the line tells us how fast they're going in this journey. So section AB will definitely be faster. Okay. Let me think of another question. Can someone type in chat, how long did they stay at the aunt's house? How long did they stay at the aunt's house? Somebody in chat. Type it into chat if you know. How long did they stay at the aunt's house? All right, answers are coming in thick and fast. All right, we're going to check the answers, then Amo's going to just confirm for us. Yes, Amo, you raised your hand. Tell us. Amo, you there?
I'm trying to unmute him.
I thought that was happening. Yeah. All right, we can't hear him yet, but I'm sure he's going to say exactly the same thing. Ah, Amo, welcome. What were you going to say for the answer? How long did they stay at the aunt's house?
I think they stayed for 5 hours.
Yes. Can you tell me how you calculated that?
Look at the point B to C.
Okay, so we've got point B's time is 13. And C's time is 1700 hours. So to find out what the difference is, so the difference, that word difference, we're going to subtract them from each other.
Yeah.
Well done, Amo. Thank you very much. But you guys are all saying 5 hours. And by my maths calculation, because 17 minus 13, well, let's get the calculator to work it out for us. 1700 hours, which is 5 o'clock, minus 13. Ah, so people hit us with the 5s first and then the 4s at the back. Ah, okay, so to confirm the answer, we have to find the difference by calculation. We subtract them and we get 4 hours. I think why people were saying 5 is they thought the graph starts at 12 and C is at 5. From 12 o'clock midday to 1700 hours is 5 hours. Maybe that's what you're thinking. But the time at B is 13, time at C is 17. To find the difference, we subtract and we should get 4. Ah, interesting. So the calculations will always confirm your answer. Okay, now, I don't know if you guys remember the measurement section. There was one lesson we did there where right at the back of the lesson, right at the end of the lesson, we came with a speed equals distance over time question. Which was when we were doing time. We were discussing the conversions of time units. And then I gave you guys a speed equals distance over time question. This question often comes up with these kind of graphs. If you have distance and time in your graph, they often ask you to do a speed calculation. Okay. So I want to see if there are people that were here in the beginning. If not, doesn't matter. You guys can still try it. I want to see if you can do question 5. I'm going to give you about 4 minutes to do it. It says here, question 4 says, how long did it take for Northwest family to travel back home? Okay. So that is from C to D. All right. So you got to do question 4 first and have an answer for that. And then you're going to use that answer because the next question, question 5, says hence. All right. That word there, hence. Now, who can tell me what that word hence means, the normal English meaning, and then what it means in this question here? Does someone want to raise their hand or you want to put in chat? Anyone want to tell me what does the word hence mean? You're going to see it sometimes in exam questions. Therefore, okay, therefore, good. Yes, it's another word for it is therefore. Okay. All right. Yes, therefore is a good answer. So it's saying, how long did it take for Northley's family to travel back home? And I saw someone already put an answer there, 1 hour. From 5 o'clock to 6 o'clock is 1 hour. And then it says, hence or therefore, which means now that you've done this and got an answer for question 4, you need to use that answer in question 5. So that word hence means now that you've got an answer in the previous question, bring it into this question over here. You need to bring that answer in to this question. So that's what the word hence means. It means, well done, you've got an answer there. That relates to this question now. Bring it into this question. So it says, hence, calculate the average speed the family was traveling for this section of the journey from C to D. Just from C to D, what speed were they going? Okay, now who can tell me what speed we used, what units we used for speed on the road for traveling? All right, hence, for this reason. Very good, Johnny. As a consequence, good, yes. What units are we going to get? Blameri. Yes, Blameri. We're going to unmute you. Yes, how are you?
I'm good, and you, sir?
I'm good, thank you.
So,
What unit?
for speed, we'll use kilometers.
We're going to use, so if you're driving in the car and you have a traffic cop on the side of the road and he stops you and he says, sorry, sir, but you were going you were going 80, and he said, what are the units that he uses? Does he say you were going 80 kilometers, or what units does he say for speed?
Once you say km.
Yes,
or
you
S.
must have. Yes, you must have km. So if you look at the formula here, we need a distance, which is the km part, and we also need a time. What units do we work with in time here?
T.
Yeah, T for time, and what are the units for time?
Minutes or seconds.
Good, minutes, seconds are also units for time, but in a long journey, what units will we use? Not minutes or seconds, what will we use?
Hours.
Good, all right. So we need km, kilometers, and we need hours. So when the traffic cop stops you, it says, sir, you were going 130 kilometers per hour. Okay, 130 kilometers per hour. So those are the units we have for speed. So it's got kilometers and it needs hours in there as well. All right, so you guys are going to do this. You should have an answer for question 4. I'm going to give you about 4 minutes. You are going to use this formula: speed equals distance divided by time. Okay, and you're going to work out the speed that this family traveled for section CD of the journey. All right, off you go. I'm sure those calculators are working overtime. Make sure you get the calculator to do the work for you. right, we're seeing answers come in. Give it a couple more minutes, and then we're going to have a look at this one. All right. I hope you guys are not just looking at the answers everyone's posting and then just copy paste there. I hope if I had to look at your calculations, I hope there's some calculations there to back up your answer. One more minute and then we'll answer this question. All right. We should have some answers in. Let's see how you guys did. Okay, so for question 4, we need that information in question 5. So let's just do question 4 quickly. Okay, so for question 4, they say, how long did it take for Northeast family to travel back home? So we first got to understand which section is the travel back home section. So who would like to help me with this answer for question 4? Anyone want to raise their hand and speak to us tonight? Tell us about question 4 and how they got their answer. Anybody?
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 Somebody?
Somebody?
Anybody?
Babalo, where's Babalo? There you see. Babalo, talk to us. How did you get this answer?
I took 18 minus 17 gave me 1. So it took them
Very
1
good.
hour to get back home.
Very good. Well done. So 18 minus 17, and that gives you 1 hour. All right. Now we're going to use this in question 5. Thank you, Babalo. Well done. We're going to use this in question 5 now. So question 5 says calculate speed. You need to work out a distance and divide it by a time. All right. So I'm going to write you a D for distance. Okay. So the distance, what distance did they travel? Well, they said in the question that the aunt's house was 50 kilometers away. So if they were at the aunt's house from section B to C, and at C, they're still at the aunt's house, but we're going to start traveling back now. How far did they travel? It's 50 kilometers away, their aunt's house. So how far did they travel to get back? And they came all the way back. It must be 50 kilometers. All right. You could actually do the same method that you use for the time to work out the distance. So the distance at C is 50. The distance at D is 0. So to work out how far that is, you can do the same calculation. You can say it's 50 kilometers minus 0 kilometers, which is equal to 50. Okay, you can do the same thing. So the distance is 50 kilometers. All right. Now we're going to write here T for time. And that comes from the previous question. Babala helped us with that, and he gave us the answer of 1 hour. Okay. Now we have all our information. Now we're going to go to the formula. And we're going to substitute. We're going to inject our information into this formula. Okay. The formula is distance divided by time. Now you can write it like this. I'm going to use D for distance divided by T for time. Okay. But surely this is the same if I write it like this. Distance over time. That's also divide, isn't it? It's the same thing. Okay. Now I'm going to replace these letters with the values. So the distance was 50 kilometers. The time is 1 hour. And if you look at this equation, like Kia always says, remember your units. I've written the units in here. When you put, yes, whenever I write units, I just think of Kia. She always says, remember your units. When you put in kilometers and hours into this formula, just like we spoke about earlier, you're going to get kilometers per hour out of the formula. Okay, so our units, kilometers per hour, is our speed units. That's what we're going to get out. And it's easy, 50 divided by 1. 50 kilometers per hour. Okay, which is very slow. Maybe they had a huge lunch and they were just trying to go slow because everyone was feeling a bit tired because their stomachs were full. I don't know. Maybe it was a beautiful day and they thought they wanted to go a bit slower. But 50 kilometers per hour is very, very slow. All right. Any questions about this? Any questions about this? Are you guys thinking, why am I getting a different answer? Well, I'll have a look at my method. Does anyone raise any questions about this? Because what I'm going to ask you to do next is I'm going to ask you to work out the speed of the first part of the journey, which is from A to B. If there are no questions about this that I've just shown you, then tell me what's the average speed that they were traveling for the first part of the journey from A to B? How fast were they going then? I'm going to give you 2 minutes. And then we're going to check the answer. Okay, really got an answer. That's a very fast answer. I hope it's a good quality answer. Your speed is good. I hope your quality is just as good. So, okay. Whoopsie. Now it's changing. It changed. You see, that's why I said your speed is good, but is your quality good? It's a good thing to be fast at getting an answer, but you've got to make sure that you do it right so that the quality of your answer is also good. Babalo, are you want to answer or do you want to ask a question? Babalo, talk to us.
I think I want to answer.
Okay. We're gonna let you answer in a minute. Just wait for everyone to finish, and then you can help me with this one. I'm very happy for you to help me.
Cool.
All right, I think everyone's working very carefully now. Okay, I don't know if you can hear it, but I think everyone's slowed right down.
Yeah.
They're going very carefully now. All right, I'll give it another 30 seconds and then we'll have a look at this one. My man Babalo is going to help us. He's going to explain to us how we got his answer. All right, I'm going to erase this. Just want to let you know, guys, if you want to remember what I've written here, you can always watch the YouTube video afterwards, but you can also take screenshots. So if you see something that you think, well, I really need to remember this, I want to look at it again, just take a screenshot. Okay, if you're on a laptop, there's a button called print screen that's going to copy what's on the screen, and you're going to have to go and paste it somewhere very quickly. With phones, you guys know how to take screenshots with your phones. All right, Babalo, do you want to talk to us and tell us how you got this answer?
Yes.
All right.
The
go ahead.
distance still stays the same as 50 kilometers, but then since the time is no longer 1 hour, it's now 30 minutes, I think you say 0.50 to get it.
Very good. Very good, Pabalo. And I'm going to stop you there before you carry on. When we did the time section, this is what threw people off. They were concerned about this. What units to put the time in. Okay. So if we want to get speed in kilometers per hour, we've got to show the units in an hour. All right. And like Pabalo said, it's from 12:30 to 1 o'clock. Okay. So at A, the time was 12:30, and B, the time was 1 o'clock. Now, you guys will look at that and say, it's 30 minutes straight away. Yes, it is 30 minutes. You're absolutely right. But how much of an hour is 30 minutes? Okay. Well, 30 minutes is 0.5 hours. Now, I'm going to use 0.5 in this calculation. And then I'm going to come back and I'm going to put in 30. And we're going to see what the answer looks like as well. But we want to have hours in our calculation. So it's half an hour. So it's 0.5 of an hour. And we're going to put that in our formula. Right. Well done, Pabalo. So 0.5 hours is going to go in. So into my formula, I inject these values in. 50 on top, 0.5 at the bottom. And I can hear Kia's thoughts are screaming right now. She's like, Dale, please put the units in. Don't forget the units. Okay. So according to the units we've used, if we put in kilometers and hours in, we're going to get kilometers and hours out of our formula. And then we just say 50 divided by half. I'm going to let the calculator work for me here. So 50 divided by half. 100 kilometers per hour. So these guys were speeding to the aunt's house. I think she promised them an awesome meal. And they were going fast to get there. And then they ate the meal and they were very full and they just went slowly back home. All right. 100 kilometers per hour. Very good, very good, very good. Sonia, you're getting 100 because you are right. Okay, well done, Ilana. Well done. Oh, you see, some answers came out and then they changed and then they changed. You've got to work carefully. All right. Now, before I want to quickly do this, okay? What if you guys used minutes instead of the hours? That's fine. You can do that. If you use minutes instead of hours, you will use 30 minutes in your formula. So I'll write there 30 minutes in my formula. But then your answer, your speed, is going to come out as kilometers per minute. Well, let's see how many kilometers in 1 minute they were traveling. So 50 divided by 30, that gives us 1.67 kilometers per minute. Okay. Now, if the question wants kilometers per minute, you would have to give the formula kilometers per minute. But if the question wants kilometers per hour, then you've got to change your time into units of hours, which is what we did over here. All right. So be careful what you give the formula, because whatever unit you give it is going to give you the same thing out at the end. All right. Well done, everyone. Very proud of you. Well, thanks, Pabalo, for all the help this lesson. It was awesome to have you helping us along the way. We're going to do the poll first, Kia.
Yes, just one simple, easy question.
All right, while everyone's taking the poll, I am going to explain very quickly for Sakile. All right, Sakile, so we need distance and we need a time. All right, we know the distance is 50. It's just a question of what time must we put in here. Now, the question said, work out the speed. It didn't say work out the speed in kilometers per hour. It just said work out the speed. All right, but we are used to speed being in kilometers per hour, which means we must give the formula kilometers and hours. Okay, so we go to our graph here and we see in our graph that the time at A at the starting is 12:30 and the time at B at the end is 1. Okay, now you guys know that's half an hour, all right? But some of you might have written it here as 30 minutes. Now you can put 30 minutes in the formula, but then your answer is going to come out in kilometers per minute. and we want kilometers per hour. So we got to change our 30 minutes into hours. 30 minutes is half an hour. So that's why we wrote 0.5 hours. Okay, so that's what we're going to put into our formula, 0.5 hours. So we come down here to our formula, put in 0.5, and 50 divided by 0.5 is 100 kilometers. And our units must be kilometers per hour because we're putting in hours.